Good morning. Today we are finally finishing off exponentials. Today's going to be your last lesson on exponentials, which is really good news. And then we are going to review and do a little graded assignment probably next week. So we're going to talk about compounding interest today, which is very real life, very real world. So the do now is just talking about buying a computer and borrowing $3,000 at 9% interest for 4 years. How much money did she have to pay back? Okay, so they tell you to use the simple interest formula. So this is your simple interest formula. I think you guys learned this back in 7th grade. I equals PRT, where if you see down here, I is your interest. That's going to be how much interest. Your P is your principal. Your R is your rate. Your T is your time. And probably the most important thing I could say about all of these formulas that we're going to talk about today, just like in growth and decay, remember that your rate always must be in decimal form. So you're going to take your 9% and convert to 0.09. So to get the interest that you would have to pay back on a principal amount of $3,000 times your rate of 0.09 and times 4 years, how much interest is that? So we're going to pull up our calculator and we're going to do that calculation. $3,000 times 0.09 times 4. Okay, and you get $1,080. Now here's what you just have to understand. That $1,080 is just the interest that you're going to be paying. So if you wanted to know how much altogether out of pocket that you would be paying, you would have to take the $3,000 and add your $1,080, which would tell you that you would have to pay back $4,080. Okay, so we had talked a lot from the beginning, just other stuff, growth and decay. Today we're going to be talking more about interest. So simple interest, I'm just going to give you like maybe one or two questions about that, but that's really back, from the 7th grade. More likely you guys are going to be seeing interest that's going to be compounding, okay? So if you notice that formula, it's pretty much your growth formula. Your initial value, which is your principal, times 1 plus, usually it's just the rate times the t to the t. And now what's the big difference? All of a sudden you're compounding. That n is the number of compounds. And that number of compounds, you're going to divide your rate by it and you're going to multiply your time by it. So what could n represent? Well, if you look down here, n could either be monthly, which would be 12, quarterly, which would be 4, annually, which just means once, or biannually or semi-annually, which means twice, okay? So you will see that you could compound this interest more than once a year, which usually will give you more money. The only other thing they could tell you is that it's compounding continuously. This is your key word. If you see the word continuous ever in a problem, it means you are no longer going to be compounding using that middle formula. You're going to use A equals PE to the RT, okay? And that's a really important formula where to get your ending amount, you take your principal times that base of E. So if you go into GeoGebra, okay, down, I'm going to just make it big so you could see it. In GeoGebra, when you go to type, notice the base of E, it's right next to your pi symbol, okay? Good to know. And if I literally just type E, notice it says 2.71828. It's just like pi. It's just this known number that we're going to use as a base in this formula. Okay, so you're going to take that principal times your base of E to the rate times the time, okay? So let's just take a few practice problems. For instance, number 1, you're taking $1,000, you're investing it at 3.5% interest for 10 years, and you're going to compound it all these different times per year. Okay, so here's what's really nice. So when I just start just the first one, right? And you're using your formula, A equals, okay, so you are going to take your principal times 1 plus your rate divided by the number of compounds raised to the number of compounds times t. Okay, so if I want to do 1, I would take my $1,000 times 1 plus, now most important, this is what kids always forget, they put in 3.5. That 3.5 never gets put in, it's 0.035, 0.035. So that's your rate, 0.035, divided by here, this is your n's, your number of compounds, 1 raised to the 1 times your time, which here was 10. Okay, so if I bring up my calculator, I'm going to clear out what I had, and watch how I'm going to type this in. 1,000, exactly how I see it. I'm going to do 1 plus. I'm going to touch on my division sign to immediately make it a fraction, 0.035. I'm going to divide it by 1, and I'm going to raise it to the, you could just do 10, or you could show 1 times 10. And there's my number. I'm always going to round to the nearest cent when it's money. So that's giving me $1,410.60. Okay? Good. Okay, so I'm going to use that. So there's my number. $1,410.60. So how is that going to change for the second part? In other words, what happens if we compound, let me get rid of this, twice a year? So that would mean you're going to take that same formula, but now you're going to take that $1,000, you're going to do 1 plus, still your rate, 0.035, but now we're going to compound 2 times. So we're going to divide it by 2, and I'm going to raise to the 2 times 10. So if I once again pull up my calculator, okay, so now I have 1,000 times 1 plus, I'm going to show my division, 0.035, divided by 2, and now I'm going to raise it to the 2 times 10, or I can even show 20. So there's my number. My number is now 1,000. I'm going to just move this over a little. $1,414.78. So not that much more, but if you notice, what happens? You maybe gained about $4 or $5, $4. Okay, so what happens if I go back here and instead of like going crazy, I literally, what's the only thing going to change with the 4? I'm going to divide by 4, and this is going to be multiplied by 4. So now there's my new number. I'm going to make that a new color. $1,416.91. Okay, so all that is now changing is that number that's being divided by 0.035 and being multiplied by 10. Again, if I wanted to show that, I could show 1,000, 1 plus 0.035 divided by 4 to the 4 times 10. Okay, so what number now would I have to change? If I went back, I can make this a 12. And I have to make that 4 a 12. So there's my new number. I'm going to make it orange. $1,418.34. Okay. I'm going to make it 365, which now is going from monthly to daily. 365. Okay, so that is going to give me $1,419.44. Okay, and now you get to, I'm going to go, what color am I going to go? Red. This word continuously. Everything changes when you hear that word continuously. Continuously is going to now tell you to use this formula, A equals PE to the RT. So in order to get that amount, you're going to take that principal of 1,000. You're going to multiply it by the base of E, and you're going to raise it to that same rate, 0.035, and the time is 10 years. Okay, so watch how this changes. Here's my number, 1,000, base of E, raised to the 0.035. Nope, I missed my 0.035 times 10. And there's my number. Not much difference. $1,419.07. So you literally squeak 3 cents out by doing it instead of every single day. Continuously is like every single second. It's constantly gaining interest. Okay, so guys, straight calculator, being able to understand where the formula is coming from and what formula to use, I think, is the hardest part. So take a look at this. It says you invest $500 in an account that accrues, okay, simple interest at 2.5%. So you have your 500, your 2.5%. How much money will be in your account after 10 years? Okay, so we could do our simple interest. We could say I equals PRT. Just remember, to get that simple interest, you're going to take your principal times your rate. Most important thing, this is what everybody's going to forget. They're going to multiply it by 2.5. It can't be. It's got to be 0.025. 0.025 times your time, 10 years. That's going to get us our simple interest. And our simple interest would be, let's clear this, 500 times 0.025 times 10. That means you made $125. But it says how much money's in your account at the end. So you're going to take your $500 and add your 125. So you'd have $625 in your account. Okay. Let's take a look at the next one. ABC Bank agrees to pay, okay, here's your word, continuously. Most important word I could show you. That changes everything. Immediately, you see the word continuously, you're immediately going to they call it the PERT formula, P-E to the R-T. Continuously means PERT. So you're going to find out how much you're going to end when you put in $1,500 times E to the rate. Okay, so we got 15, 6 years, rate of 4.2. Remember, 4.2.042 times your time, 6 years. Okay, so once again, look where that E is going to be. Sorry. Okay, so it's 1,500 base of E raised to the 0.042 times 6. So it looks like we have $1,929.89. Always round to the nearest cent. You want every single cent of your money. Okay, good. Let me get this a little smaller. Okay, this is a good one. So in number 4, they say Jessica's investing $15,000 and an annual interest rate of 4%. Find the balance after 6 years if your investment is compounded, and they have 3 different things: quarterly, monthly, continuously. Okay, so how many quarters are there in a year? This means, quarterly means N equals 4 quarters. Monthly means N equals 12. And continuously means PE to the RT, okay? You're using that base of E. Okay, so let's write that formula. So we are going to say Let's use, remember, you're going to be using your A equals P times 1 plus R. Okay, so you're going to say, take your investment P, 1 plus R, divided by your N, to the N times your T. So in order to get how much you would have, you would take your principal of $15,000 times 1 plus your rate, 0.04, divided by here 4. Okay, your N is 4 to the 4 times 6 number of years. So that's going to tell us how much money you would have after $15,000. So you're going to take your 15,000 times 1 plus division 0.04 over 4 raised to the 4 times 6. Okay, that's your number. Looks like $19,046.02. Because look at that 1. Look to the right. That 9 makes that 1 become a 2. Okay, so how is it going to change for monthly? The only thing that's going to change for monthly is now, instead of dividing by 4, you're going to divide by 12. I'm going to take my 15,000, 1 plus 0.04 divided by 12 to the 12 times 6. So really, you could go back in if you wanted to, just to make life easier. Make that. Can you? Let's see if it changes it. Yeah, it does. So you can make the 12s, make the 4s become 12s, and now you have $19,061, so just a little bit more, and 13 cents. Okay. In the last one, your PERT formula, because you see this word continuously, immediately you write A equals PE to the RT. And you're going to take your $15,000 times the base of E to the 0.04 times 6. Okay, so I'm going to go into here and do 15. Oh, I'm in the wrong spot. Here. 15,000 times the base of E raised to the 0.04 times 6. So it looks like $19,068.74. 19,068 and 74 cents. So clearly you see which one is going to give you the most money, and that would be continuously, because the more you compound, the more money you are getting. Okay, so let's take it in another one. In this next one, Angela is being born. When she's born, her grandmother deposits $5,000 in her trust fund that's earning 3.75% interest compounded continuously. Key word. What formula are you going to use immediately when you see continuously? PERT, A equals PE to the RT. How much money will Angela have after her 21st birthday? Okay, so we want to know how much money is she going to have when they take $5,000 times E to a rate of, remember, 3.75, move it over 2 to the left, 0.0375 is going to be your rate. 0.0375 is in your exponent times, well, how many years? When she was born to her 21st birthday, we're going to say 21 years. So we're going to go into our calculator, and we are going to do, let's clear this to make it easier, 5,000 base of E raised to the 0.0375, that is the most important thing, times 21. So how much money is she going to have? Man, she more than doubled her money in 21 years. So she'd have $10,989.47. There's her money. Okay. In this next question, they're giving you $1,000, 4% interest compounded quarterly. Quarterly tells you that N equals what number? 4 after 3 years. So let's talk about this. If A equals, now you're going back to the compounded formula. It doesn't say continuously, so you're going to use 1 plus your rate divided by the number of compounds to the number of compounds times your time. So here, you're going to do your principal, $1,000, 1 plus your rate. Remember, 4% is 0.04, divided by your number of compounds, 4, to the number of compounds times your time, 3 years. So if I go in here, I'm going to do 1,000 times 1 plus, I'm going to divide and make it 0.04, divided by 4. Don't forget to raise it now to the 4 times 3, which is going to give you $1,126.83. Okay, there's your money. Let's see, how many do we have left? Not so bad. So maybe I'll let you guys try the rest. I will post answer key. Please take note in the next example. They're talking about continuously, which means every formula here should look like this. Okay, every one. You're taking, I'll do this one for you, 10,000, 4%. For this is just different amount of years. So here, you're taking your $10,000, base of E, raised to the, remember, 4%, 0.04. And now you're going to raise it to the, here, the first one is 10 years. Okay, so, not that, this one. I am going to clear this, and I'm going to do 10,000. Did I do too many? 10, 1, 2, 3. Base of E raised to the 0.04 times 10. Okay, so that is my number. $14,918.25. So 14,918.26. Okay, how is that changing for 30 years? The only thing that changes is your exponent. So look, now I have, wow, much bigger. You leave it in for 20 more years, you now have $33,201.17. And the last one, I believe, is 50. So now if I go back and just make it 50, I have 73,000. Let me go new color. This one is $73,890.56. Okay? So that is going to leave you with maybe like 3 or 4 more questions. I want you guys to practice on your own. I will post the answer key. Have a wonderful weekend. Don't do any work over the weekend. It's going to be a beautiful weekend. Enjoy it. And we'll talk again on Monday. Let me know if you have any questions.